In today's lesson, we're going to be covering the muscular system. For this particular chapter, we are going to be focusing only on the skeletal muscles. In a previous chapter, we did talk about the cardiac and smooth muscle as well, but for this particular chapter, when we're talking about the system as a whole, we're going to be referring to the skeletal muscles. And what we're going to see is that the organization of those skeletal muscles is going to dramatically affect how much power you're going to have in that muscle, the range and the speed of movement that you're able to have based on how the muscle is going to be organized. What we're seeing on this slide is the different configurations you can have within the fascicle of the muscle. Now, from the previous chapter, when we talked about how the fascicles were going to contain the muscle fibers within them, or the muscle cells, you can see that those fascicles can be arranged in different ways. So the first one we see in part A is going to be a parallel muscle. The parallel muscles are going to have fascicles that are running parallel to the long axis of the muscle. These can be flat or spindle-shaped muscles, and they'll have a central body or a belly area. So you can see here is a cross-section with the belly, and then you can see the traditional fascicles that we talked about with these circular sections within the whole muscle from the previous chapter. The entire muscle with this type of arrangement can shorten about 30% when it is contracting, and you're going to get an even distribution of the pull on either side of the muscle based on where it's connecting to the bone. So you can see A, B, and C are showing different types of parallel muscles, and they do have different arrangements. So for instance, when you look at B with the rectus abdominis, you can see that there is going to be this band that is going to be right in the center, which is creating that linea alba of these parallel muscles that are going to wrap around like this supinator muscle. That is going to kind of wrap around where the bone is going to be. The next group are going to be the convergent muscles. So with the convergent muscles, you're going to have a wide base at one end where it's going to have a very broad side, and they are going to converge to one particular attachment point on the other end. So oftentimes you're going to find a tendon on one end of this. Sometimes you can find an aponeurosis, which is like a tendon, but it's going to be a flattened sheet, or a raphe, which is going to be a slender band of collagenous fibers that are kind of holding it in place. Because of this broad base that we have, you're going to have it pulling from different directions. So the pectoralis major is going to be an example of that. So you can see that over here where you have that broad base, and they're all going to come together to this one central point. Notice with the pennate muscles, you have a few different types. They're going to all form a common angle, and then they're going to have tension that's going to be created because of that common angle where they're going to attach to the bone. So compared to like a parallel muscles, they're not going to be able to move their tendons as far, but they can develop more tension within those muscles, and they're going to actually have more myofibrils than compared to a parallel muscle. So do notice the different types with unipennate, bipennate, and multipennate muscles that you can have. Our last major group that we're going to be looking at are our circular muscles. Circular muscles are oftentimes referred to as sphincter muscles, and as you can see, they form these little concentric circles around some sort of opening that's going to be in the middle here. So you can see in the contracted version, that opening is going to be much smaller, and then when it is relaxed, it's going to be more open. Now, when we're talking about skeletal muscles, they're almost always going to be attaching to bones, hence they're being called skeletal muscles. But that site of how they're connecting to that bone is going to affect the force, the speed, and the range of motion of what you're able to do with that particular muscle. Now, what we're using is we're implementing basically a lever system. So when we talk about a lever just in general physics terms, lever is going to be some sort of rigid structure, and it's going to move around some sort of fixed point, which is going to be considered our fulcrum. And so using a lever allows you to generate much more force than you would typically without having that rigid structure that is going to have that fulcrum area. So we are going to want to overcome what is going to be shown here as an L or a load. So the load is what you're going to want to move. The F is being shown as a fulcrum, which is going to be that fixed point, and then you're going to have this applied force that's going to be in there because that's where you're going to actually be contracting your muscles. So our classes of levers that we are showing here are all basically going to be relative to where these structures are, the load, the fulcrum, and the applied force, and where they are relative to each other. The lever that you're using can change the direction of your applied force. So even though you could be pushing in one direction, it's actually pulling in the other one because of it. It can change the distance and the speed that's produced by that applied force. And basically it's changing the effective strength of the force. So just like you trying to use a crowbar, it's going to allow you to lift more load because your applied force is going to be greater than you would just trying to pull it on its own. So we have three different classes of levers in here. And so for our first class of lever, you can see that the load is on one end, the fulcrum or the fixed point is going to be on the in the middle here, and then the other end is going to be the applied force that you have. So our applied force, the example that we have here, is going to be our trapezius muscle and our semispinalis capitis right here. So we have these muscles which are pulling down and contracting. As they pull down and contract, they're pulling on your skull, which is going to be that rigid lever itself. The fulcrum is going to be this point right here in the skull where you're basically going to be rotating back and forth through, and the load is picking up basically the weight of your facial bones over here. So as you apply this force, which is pulling downward, it's then going to allow it to pivot on the fulcrum, and it's going to move the load up. So as you can see, now your head is going to be tilting back because of the force of contracting these muscles. So that's a first class lever with the fulcrum in the center. Here we have a second class lever. With the second class lever, the fulcrum is going to be on one end, the load is going to be in the middle, and then the applied force is going to be in the opposite end of the fulcrum. So we can show here with our gastrocnemius, this is basically your calf muscle. When you're going to contract that, it will pull the muscle up. The load is going to be right here around your ankle portion, and then the fulcrum or your fixed point is going to be right here at the ball of your foot. So when you apply that force of that gastrocnemius, it's going to pull the load because the load is pushing downward on us, and we're going to pull it upward and we're going to get on our tippy toes. This is a second class lever because the fulcrum is at the end and the applied force is on the other end with a load in between. The second class lever is going to allow you to use a small force, and it can move a large weight with it. So that's one of the benefits of that, because you're creating this larger weight that you're able to lift with really a minimal amount of force that's going to be applied to it. A third class lever is going to be like a pair of tongs that you have here. The applied force is actually in the center, the fulcrum is at the end, and then the load is on the other end over here. So like when you squeeze tongs in the center, they're attached together at this point here at the fulcrum, and then that moves the two ends of the prongs together for the tongs that you have here. So an example on the body is going to be our biceps brachii. So our elbow is going to be our fulcrum. Our applied force is going to be the bicep brachii above it, and if you're doing a curl, you're then lifting up the weight of whatever you're holding in your hand or the hand itself. So here's our fulcrum, there's our applied force, and then our load is going to be moving with it. And so that is going to be a third class lever. The third class lever is the most common lever that you're going to have in the body. Now, one of the things we're oftentimes going to refer to when talking about muscles is going to be the action of the muscle. And sometimes it's called the line of action. So it can show you how that muscle is going to apply force and what direction that is going to cause the joint to move because of it. And so it's always going to be relative to the axis of the joint itself that's going to allow us to contract our muscles and pull on that lever that's going to cause the action that we're looking for. So some of the terms you need to look at is going to be origin, insertion, and action. So action is that specific movement that's produced when you contract that muscle. When we talk about the origin is going to be the point of attachment of the muscle where it's going to be attaching to a bone that is fixed or not movable or less movable. Then you're going to have an insertion, and that's going to be the attachment point where you're attaching to a bone that is going to be movable. So let's give an example of where the origin and insertion is going to be. Looking at this one right here, we have our biceps brachii. So you can see your biceps here, and then you can see your triceps down here on the back side and the posterior side. With the origin and insertion, you will have two different areas where we are going to be attaching. So this is a bicep, and it's called bicep because there are two attachment points. Both of these attachment points, you don't get a good view of it here, but are going to be to the scapula. So we have two different areas of the scapula with a coracoid process here, and then this is going to be a tubercle that's on the top of the glenoid cavity. These two are going to be attached to the scapula, which is an immovable bone, so that is not going to be moving around. If this muscle is going to contract and get shorter, it is going to then pull on the movable bone that is going to be below it. So we can see here that we are attached to the forearm, specifically to the radius. So when a contraction occurs and the muscle shortens, the immovable bone or the origin that you have for the attachment point is not going to go anywhere. So the only thing that's able to move is the forearm. And so when the contraction occurs, you will have flexion, which will bring the forearm inward because you are pulling on the radius, and that movable attachment point is going to move the arm upward because the scapula is not going to be able to move. We can have a flexion and an extension of a joint. When we say something's going through flexion, flexion means that you are decreasing the angle between the two bones within that joint. If we're saying extension, we're then increasing the angle instead of decreasing it. When we're comparing abduction to adduction, these are going to be very close in spelling, so just a one-letter difference with ab and ad. So abduction with a B is going to be moving away. So if like someone is abducted, they're taken away. Adduction is going to, so it's going towards that midline as opposed to away from the midline, which would be abduction. This is going to be referring to a lateral to medial movement side to side within the body. Whereas when we talk about flexion and extension, this is an anterior to posterior movement, that front to back movement that we have. But you also have rotations. So rotations can be medial and lateral rotations. So what we see when we're looking at these muscle actions is that you have interactions in groups of muscles, and it helps to maximize the efficiency because the smaller muscles tend to reach their maximum tension first, and then the larger ones will be able to come in, and those primary muscles will also be able to increase tension. And so you're going to end up with these groups of muscles that are working together to perform that action. So there is more terminology that you're going to have to know for this one as well. So for this, we're going to have the agonist. The agonist is also referred to as our prime mover. And the agonist is going to be the main muscle that's responsible for producing that particular movement. So if you do a particular movement, it's the muscle that you generally think of as doing it. But that agonist is not doing this on its own. It's going to have a synergist oftentimes, which is a smaller muscle that is going to be helping it. But they're also going to have an antagonist, and the antagonist is going to oppose the movement of the agonist. For instance, if we look here at this flexion and extension, or if you do a bicep curl, it's going to cause you to flex and decrease that angle and pull the arm upward towards like the bicep brachii. But at the same time that this is going to be flexing to do that, the extensor muscle on the other side, the triceps brachii, is going to be opposing that motion. So the flexor and the extensor are both working together, but they're opposing each other's actions. So when we want to actually bring this arm back down, the extensor muscle will then do its work where the triceps brachii is going to be contracting, and it's going to allow us to pull and cause the action to go downward in that extension motion. So when we see this flexion and extension, abduction and adduction, these different rotations, those are going to be opposing movements to each other. So those opposing movements are going to be because you have an agonist and antagonist that are going to be working as a group to kind of work these together. So when one contracts, the other one is going to stretch. Now, just like the skeletal system where we had axial and appendicular skeletons, we will also have axial muscles as well as appendicular muscles. And these are going to get a little bit more confusing than we saw in the skeletal system because it's not just where they're physically located, it's what they're causing the action for or the contracting, and the action is going to be happening because of the contraction that they're doing. So sometimes you're going to see some overlap in what you think might be an axial muscle, but it's actually considered an appendicular. So what we're looking at for the rest of this chapter is I'm going to go through the different groups of muscles that you're going to need to know, and I'm going to highlight the ones that you need to know or the ones that you don't need to know. Now for this slide in particular, there were so many that I actually wanted you to know that what I've done is I highlighted and read the ones you do not need to know. So what you're going to see is as we go through the rest of this chapter, a lot of these are going to be repeated because you're just going to see them from a bunch of different views depending on functionally what they're doing and when they're doing it. So a lot of these are going to be repeated. So make sure you can identify them both on this, superficial anterior and posterior view, as well as if we go closer up on a particular group of muscles that you're able to identify them as there as well. So when we're talking about the skeletal muscles of the body, you have more than 700 different skeletal muscles. I'm obviously not going to make you know all of them, but do make sure that you're paying attention to whether or not they're considered an axial or an appendicular muscle. Now, when we talk about your axial muscles, those are going to be any muscles that are used that are going to help you position your head, your vertebral column, moving your rib cage up and forth, and forming your pelvic floor area. So again, like the top of the skull all the way down to the coccyx, that was going to be considered your axial skeleton. About 60% of your muscles are going to be comprised of that axial muscle group. When we talk about your appendicular muscles, a lot of times they're going to be attached to that trunk of your body, which is going to make you think axial, but they're actually there to support and move your appendicular skeleton.